Alright, we're going to be taking the derivative of y is equal to the natural log of x. Now I find taking derivatives of natural log functions pretty simple, and once you get it down you'll find that it's actually pretty easy. But the way this works is you take the derivative of what's in parentheses, so the derivative of x is 1, and then whatever's in parentheses you just rewrite it, and it's just that simple. Let's look at some more. Alright, we have the y is equal to the natural log, and in parentheses e raised to the x squared. So we've already taken some derivatives of the exponential function with base e. So what did I say? We take the derivative of what's in parentheses, so the derivative of ex raised to the 2 is 2x ex squared, right? That means you take the derivative of the what's up here in the exponents. The derivative of x squared is 2x, and then you just rewrite the whole thing. Okay. And then taking the derivative again for this natural log function, the rule is once we took the derivative of what's inside, then we just rewrote what's inside down here. And of course we simplify it down. We have ex to the squared, those cancel out, and you're just left with 2x. Alright, we have t of x is equal to the natural log of x squared plus 4x plus 1. So we take the derivative of what's inside, just like I've got it stated here, and then you just rewrite the whole thing, put it in the denominator. So the derivative of what's in parentheses was 2x plus 4, and then we just rewrote the whole thing down here in the denominator, and we're done. Alright, we have y is equal to the natural log of x plus 1 over x minus 1. Now you definitely don't want to do what we've been doing in the previous ones the same way. What we're going to do is take the properties of natural logs and break this up first. So we can write this, we can rewrite this as the natural log of x plus 1 minus the natural log of x minus 1. And it's a minus here because we've got a bar right here. Okay, so think of this bar here as getting really small and turning into a minus sign. That's kind of the way I remember it. But I don't know, if you do these enough, you don't need anything to remember it. Alright, so we want to take the derivative of each one of these separately. So remember, we take the derivative of what's in parentheses, so the derivative of x plus 1 is just 1, and then you just rewrite x plus 1 down here in the denominator. Okay, minus derivative of x minus 1 is 1, and then you just rewrite it. Alright, now I want to get a common denominator. So I'm going to multiply x minus 1 over x minus 1. And then we have an x plus 1 over here, so I'm going to multiply x plus 1 over x plus 1. Fractions are easy. I don't know why people make this stuff so difficult. Alright, and now since we have a common denominator, we're going to go ahead and simplify this thing down. Right, so I went ahead and simplified the top. Now we can just add the tops together. So we have x minus 1 minus, now I went ahead and distributed this minus across. So you can see that's the reason there's a minus here, because I went ahead and distributed it across. So we have an x, a minus x, those cancel out. You have a negative 1 and a minus 1, that gives us a negative 2. But bring the negative out here in the front. Alright, don't leave it up here in the top. And then I went ahead and multiplied these two together. Right, x times x is x squared, x times negative 1 is negative x, 1 times x is a positive x, and 1 times negative 1 is just negative 1. So hopefully you've remembered how to do that. If not, that was the refresher. And then just simplify it down. But see, these are really both the same other than we have a plus and a minus, right? So all you got to do is go x times x is x squared, and plus 1 times minus 1 is negative 1, and guess what? You're done. Alright. Now let me bring up that formula page real quick, coming from that main calculus page. Alright, so this is kind of where we were at here. Taking u, the derivative of it, and then just rewriting u. Now remember, u is a function. It's not just a single variable like x. And this was the other part to that formula base where e, and we'll get to some of this other stuff here in a minute. But this is kind of this one, and this one here is what we kind of focused in on.